Okay, so today we are taking notes on exponential functions. Go ahead and write on your note paper for the topic exponential functions. You can also go ahead and put your name and the date. All right. I want you guys to take a look at this table here. Looking at the table, what is the pattern that gets us from one value to the next? How do we go from 500 to 600, 600 to 720, and so on? What are we doing each time? I want you to go ahead and pause the video and try and figure it out. What are we doing each time, the same thing, to get these numbers? All right, have you figured it out? Well, if you take a look, it turns out that each time we are multiplying by 1.2. You can go ahead and pull out a calculator and look. 500 times 1.2 is 600. 600 times 1.2 is 720. 720 times 1.2 is 684. And 684 times 1.2 is 1036.8. All right? So notice how each time we are multiplying by the same number. So I want you to think now, we've seen a lot of linear functions. What is it that happens with a linear function? With linear functions, each time we add the same amount. So from 500 to 600, I added 100. And so then the next one, I'd add another 100, and I'd get 700. I'd add another 100, and I'd get 800. So that's what happens in a linear function. But in this case, instead of adding the same amount each time, we're multiplying. So instead of adding 100 each time, we are multiplying by 1.2 each time. And answer the next two bullet points. Why is this not linear? Why is this function not linear? And what is happening instead? All right, so what did you guys put down? I said that it's not linear because we are not continually adding, and instead we are constantly multiplying. So the pattern that we have just observed here, this is an exponential pattern. And we say that an exponential function is a pattern that constantly multiplies. Go ahead and write this in your part of the notes. An exponential function is a pattern that constantly multiplies. So what does an exponential function look like? Well, it looks like this. F of x is equal to a times b to the x. Notice here how b is in parentheses, and so the x is only applying to the b. You might want to make a note of that in your CCQ. Say x only affects the b. You can make a note for yourself if you want. So what do each of these numbers mean? Well, we have an a. The a is our initial value. You can also think of it as the thing we start with, our starting value. Okay, then what is b? B represents the ratio of change. When you're looking at a function, you can figure out what b is because it's the number that you keep multiplying by. All right, we're going to be talking a lot about finances, and when we get to that point in time, you'll be thinking often about it as the percent that you have or the percent that you keep. So if you want to put this in your notes so that when you look back at it in the future, you can think about it as the percent that you have or keep. It's okay if this last one doesn't make a lot of sense right now. We'll talk about it more in class. But the important thing to know is that B represents the thing that you keep multiplying. So the X represents our input value. You can also think of it as the number of times we're multiplying this number. So if I had X equals 3, I multiply the original number by 1.2 3 times. In our project, at the end of the unit, X will most often represent something related to time. So like the number of days or the number of years. So let's go ahead and walk through an example. Using the table above, what is my A? Remember that our A is our initial value or starting value. So looking at the table, I want you to figure out what is our A. So our A in this case is 500. Because if we look at the table, that's the value we're starting at. We're starting at 500. So go ahead and write in your notes. A is 500 because it's our starting value. What about B? B represents our ratio of change, the number that we keep multiplying. So looking at this table here, what's the number that we keep multiplying? Go ahead and try it out for yourself. Write it in your notes. So our B in this case is 1.2 because we keep multiplying by 1.2. If I'm looking here, each time I keep multiplying by this value. So that's our B. So looking at our formula here for how to write a function, I would say that this one is f of x is equal to a, which is 500, times b, which is 1.2, to the x. So this is our function.